All right, everybody, let's do this. This is a little lesson on inductive reasoning along with some conditional statements. Now, inductive reasoning is basically coming up with conjectures, which would be an educated guess, and then trying to determine if they are true or false. Now, to prove a conjecture false, all you need to do is come up with a counterexample. So, your counterexample, of course, has to prove that the conjecture you made is false. If you cannot come up with any counterexamples, then your conjecture is true. So a little example of that would be B is between A and C. So our conjecture is going to be that B is the midpoint of AC. So you think about that for a minute, and then all of a sudden what pops into your head is that is a false statement because just because B is in between A and C does not mean it has to be a midpoint. So we can have B sitting over there where this is 3 and this is 7 and AC is 10. Okay, so just because you have an example that could be true means it has to be true in all cases for the statement to be true. Okay, so in this case, that conjecture is false. So that's an example of conjecture with a counterexample. An idea of a true statement would be if you have a 30-degree angle, then it's acute. Well, yeah, true statement. There's not much you can do to prove that otherwise. So let's move on to the next topic, and that's conditional statements. Now, conditional statements are also known as if-then statements most of the time, where you have a hypothesis and a conclusion. So they're usually written if and then your hypothesis, and then we have then our conclusion. So what we can do is we can write many different kinds of statements as conditional statements. So the statement we have here is parallel lines do not intersect. That's a true statement. So how can we write that in conditional form? All you would have to do is if two lines are parallel, then they do not intersect. Okay? Now, they don't have to be like, you don't say if parallel lines then do not intersect. You can reword it a little bit so it makes more sense. So if two lines are parallel, then they do not intersect. Your hypothesis would be two lines are parallel. And then your conclusion would be they do not intersect. Okay, so the hypothesis is what comes after your if statement, and the conclusion is what comes after your then statement. Okay, so that is a conditional statement. Now, there's all sorts of different ways you can play with conditional statements, and we're going to talk about that next. Just so you know, usually conditional statements are in the form if P then Q. P would be your hypothesis, and then Q would be your conclusion. Okay, there's other ways to say it. P implies Q. There's a little arrow, which means P implies Q. So we're going to talk a little bit more about that. And those are conditional statements, which we just said P and Q. And then we have what if you reverse it? Converse would be if Q, then P. Then we have an inverse. Now, these little squiggles means negate or not. So the inverse would be if not P, then not Q. And then the contrapositive would be negating the converse. So that would be not Q implies not P. Now, you can also write a biconditional statement. That's usually used when both the conditional and the converse are both true. So that would be, example, it would be P if and only if Q. That would be a biconditional statement. So these letters sound a little funny. So why don't we do an example so you can see what it is that I'm talking about, and we'll talk about which statements are true and which statements are false, stuff like that. So The first one we're going to do is the conditional statement is if it is raining, then the ground gets wet. So we have our hypothesis and we have our conclusion. So to write a converse statement, the only thing you have to do is flip your hypothesis and your conclusion. Now, these are not always true. So let's first think about the conditional statement. If it is raining, then the ground gets wet. That's definitely a true statement. So now let's do the converse. If the ground is wet, then it is raining. And now you think about that for a minute, and then you ask yourself if that's a true or a false statement. And that would be a false statement. And all you have to do is come up with a counterexample. And we can say it's a sprinkler. In the summertime, we water our lawn sometimes, and the ground gets wet, but it's not raining. Usually we run the sprinkler because it isn't raining, but the ground is still getting wet. So all you need is one counterexample to prove that the converse of that conditional is a false statement. So now let's go take a look at the inverse. The inverse says, if it is not raining, then the ground is not wet. And we can go right back to the converse and say that's also a false statement for the same reason as the sprinkler. If it's not raining, the ground can still get wet. It could be a sprinkler. It could be you were washing your car. It could be any number of reasons why the ground is wet, but it's not raining. So usually if the converse is false, so is the inverse. So now let's go back to the contrapositive. The contrapositive should be true if your conditional statement, the original statement, is true. Let's check it out. If the ground is not wet, then it is not raining. And that would be a true statement. See, if the conditional is true, then the contrapositive is going to be true. And the reason why would be, well, if the ground's not wet, it's impossible for it to be raining, because if it was raining, then the ground would be wet. Okay, so there you go. So a converse just switches. An inverse doesn't switch the hypothesis and conclusion, it just negates them. And their contrapositive negates and switches the hypothesis and conclusion. And if the original statement is true, then the contrapositive is going to be true. If the inverse, or if the converse is true, the inverse will be true as well. Now, the biconditional is true if the original conditional statement and the converse are true. In this case, it would be a false statement. That would be saying it is raining if and only if the ground is wet. And we already know that is an incorrect statement, going back to our sprinkler again. Okay, so in this case, the biconditional would be false. So now let's look at an example where everything is true. If an angle is 90 degrees, then it is a right angle. Why don't you pause the video and try writing out the converse, the inverse, the contrapositive, and the biconditional on your own. So let's see if you got it right. If an angle is 90 degrees, then it is a right angle. So the converse would be, if an angle is a right angle, then it is 90 degrees. That is also a true statement. The inverse would be, if an angle is not 90 degrees, then it is not a right angle. True, if it's 89, it is acute. If it's 100, it is obtuse. If it's 180, it's straight. But anything other than a 90-degree angle is not going to be a right angle. Contrapositive, if an angle is not a right angle, then it is not 90 degrees, a true statement. So since the conditional and the converse are true, then that means the biconditional will be true. So we can write that statement as an angle is 90 degrees if and only if it is a right angle. So everything is true, as I mentioned before. So that means we are finished with this. Think about some of the conditional statements you've heard over and over since you were a kid, such as, if you eat your dinner, then you can have some ice cream. You've had all sorts of different if-then statements come up in your life, and it's not going to stop. So there you go, a little lesson about deductive reasoning, inductive reasoning, contrapositive, all that kind of fun stuff. So that's it for this one. This is Longo, and I'm out. See you, bye.